So, hello everyone. Welcome back to all of you on this Unacademy channel. And here we are just going to start with the term second exam syllabus. And as you know that so many topics we have already completed. So if you are also belong to the class 11th or 12th from ISC board, so definitely this session are going to be beneficial for you. So how many learners are new here? First, I would like to introduce myself to all of you as I'm Sanam Jain and I'm a maths educator on Unacademy and I've done masters in mathematics and I'm having more than 8 years of teaching experience of teaching mathematics in different boards like CBSE, ICSE, ISC and other state boards also. Right. So definitely I can help you to reach the next level of learning of mathematics and you will learn so many things related to your syllabus. Okay. So you can definitely be with me for the today's topic that is indefinite integral part 1. Right. That means if you are one of them, if you are one of them that you have not studied anything about integration, right? You're zero in integration, then this session is just for you. Right, because in this session we are going to complete the whole understanding about integration. I'll start from the scratch. So if you have not studied anything about integration, that means you can get so many benefits from this session, right? So definitely you can be with me for a for completing this session, and you can also follow us on the Telegram that we are having some our channel on the Telegram where you will get the updates related to your special class which is going to be conducted on regular basis related to ISC board and ICSE board for maths, physics, chemistry and bio. So if you would like to join these free special classes, then you can join our Telegram channel and the link is already given in the description box. Okay. So as you know that here we are also on YouTube channel now. So we are expecting a target of 1,000 subscriber from your side, and we know that you all will give so much love to us. So please like our channel and subscribe us, and you can click on the bell icon so you will get the every updates related to the classes. So let's start with the session today. As we know that today we are going to discuss about the indefinite integration, right? So I hope and I'm expecting to all of you that you have studied about differentiation. And if you are knowing about differentiation, then this integration becomes very easy for you, right? As if you know that when we talk about this indefinite integration, we always take the reverse operation in differentiation. That means whatever we are doing for differentiation, we have to just apply the inverse operation in differentiation. So you will be getting the integration, right? Or you can say indefinite integration. So we can call it also as antiderivative because differentiation is known as derivative. So you can call it antiderivative, right? So when you are finding the reverse operation of derivative, that means you are finding a reverse operation of derivative. So you'll be getting like antiderivative, right? Anti word means just opposite. That means you are just making the reverse of it. Somebody is saying something to you, right? And you are doing just opposite of it. Okay. Maybe your parents have said, today you are not going anywhere, right? Today you have to stay at home and you have to study. But what you are doing, maybe you are just going outside with your friends. So that means you are just doing just anti what your parents are saying, right? So this becomes anti statement. So similarly, when we talk about differentiation, the process we apply for differentiation, if you are doing the reverse of it, it will be known as antiderivative. Okay, or we can say integration. So here, Sawyer is, I can see Sawyer is here. So please write the statement in English so it can be helpful to us to understand. Right? Please write in a proper way. Sawyer var. So it will be better with you to communicate. Okay. So how many students are watching this lecture? So let me explain you about first of all the notation of integration, right? As you can see that for differentiation, what we do, we always use d over dx, right? And here we always write the function. Just suppose sin x. Okay, so we always get cos x. This is the formula that we apply in differentiation. So if you are allowing this as d over dx of sine x is equals to cos x. This you are applying for differentiation. So this is a some kind of notation that you are writing d over dx, which shows the rate of change in the value of sine x, right? This shows the rate of change in the particular quantity. Similarly, when you write this as integration, this is a sign of integration. So this is actually known as, wait a minute. So this sign, this is called sign of integration. Understood? This is a sign of integration, or you can say integral. Okay. And when you talk about this function, the function you are going to integrate, that function is known as integrand. The function is known as integrand. Understood? Now when you talk about this dx, right? When you talk about this dx, this is known as variable of integration. Variable of integration. Okay. Now the result you are getting after integration, that result is known as integral. That result is known as integral. Okay. And this c is known as constant of integration. Constant of integral. Okay. So these are the terms, or these are the notations which we use to show the integration part. Okay. So how many are able to understand? Just write in a chat box, yes, you understood. Okay. So here I am going to repeat it, as this is a sign of integration. Okay. As you form S, you have to just draw like this. Okay. So this becomes your integration sign. So integration, this is a sign of integral. This function which you are going to integrate, this is known as integrand. Dx is known as variable of integration. The result you are getting after integration, that is called integral, and here you are writing plus c. Okay, so this is your constant of integration. Now a question comes in your mind, sir, why are we using this c over here? That means why are we going to add any constant after integration? So let me help you out. See, as you know, the d over dx of sine x is cos x, right or not? And if we find out d over dx of sine x plus 3, what will it be like? This will also be as cos x, yes or no? Because this becomes 0. Or just suppose if you are finding d over dx of sine x plus 5, then what will it be like? Again it will be as cos x. Or just suppose you are finding d over dx of sine x plus c. So what will it be like? It will always be cos x. Yes or no? So that means if we are finding the differentiation by adding any constant in the function, you will get the result as same. Yes or no? So this shows when you integrate this function, that means when you integrate the function, this c should be there, because this is a reverse operation, right? As you know, if we are finding a differentiation of sine x, it becomes cos x, right or not? So when you find the integration of cos x, it should be sin x. Understood? It should be sin x. That's why we use this c over here. Understood? So basically, if you just suppose you are going to integrate cos x over here, right? If you are going to integrate cos x, so what will it be like? If you are going to integrate cos x dx, you will be getting sin x plus c. So see, you can see here that when you are integrating any function, you are also getting again sin x plus c. Understood? So that's why this constant can be anything. that can be 3, that can be 5, that can be any number, any real number can be there. So if you add this number in the function, this always give the same result. That's why we always write c after integration. Okay, because without any constant the value is same, then if we are using the constant the value is same. That's why we are always writing plus constant over here, which is known as constant of integration. I hope you understand this. Okay, now see, there are some standard forms related to differentiation and integration, right? There are some standard forms which are related to differentiation and integration. So here you can see what is the differentiation of x power n plus 1 upon n plus 1 is equals to x power n, right? You have studied about the differentiation of d over dx of x power n, right or not? So if you find this, you will be getting like n x power n minus 1, right? Or just suppose if you are finding d over dx of x power n plus 1 upon n plus 1. So what will it be like? See, you know very well 1 upon n plus 1 is a constant value which you can take outside. And here you will be finding d over dx of x power n plus 1. Now you can apply this formula over here. D over dx of x power n is equals to nx n minus 1. So when you apply this, 1 upon n plus 1 into, you will apply over here, so it will be like x power n plus 1 minus 1 divided by, wait a minute, okay. So you can see here that you will be getting like x power n plus 1 minus 1 and into, you should have n plus 1 also, right or not? This is only the formula that n x power n minus 1. So here n is replaced by n plus 1. So n plus 1 into x power n plus 1 minus 1. So these two will be cancelled out and you will be getting, this will also be cancelled out. So you will be getting x power n as the answer, right or not? So as you know, the differentiation of x power n plus 1 upon n plus 1 is x power n. So if you integrate x power n dx, you will be getting x power n plus 1 upon n plus 1, as this is a reverse process. Understood? Similarly, you can see here, as you know, d over dx of sin x is cos x. So when you integrate cos x, okay, you will be getting sin x. And always you have to write c over here. You have to write plus c in every integration, because when you will be getting the result, you always write c over here. Reason, if you are going to differentiate sin x, you are getting cos x, right? Or just suppose if you are going to differentiate sin x plus 2, so still you are getting cos x as the answer. That means what? If you are finding integration of cos x dx, it should be like sin x plus c. That means any constant if you are using over here in the differentiation, it will come back again in the form of c. Understood? That's why we are using c as a constant of integration. I hope you understood this. Right. Now similarly, d over dx of cos x you know is minus sin x. So definitely when you integrate sin x, you will be getting minus cos x plus c. This is just a reverse operation. If you are able to learn the formulas of differentiation, then you have no need to learn the formulas for integration, because this is just reverse. Right. So here one more formula we have like d over dx of tan x, which is sec square x. Right. So integration of sec square x will be tan x plus c. Understood? Now, if differentiation of cot x is minus cos x square x, so it becomes integration of cos x square x dx will be minus cot x plus c. So like this, you can easily integrate the function, right? Now, let me help you out with the next one. There are more some standard form which you can use. As you know, d over dx of cosec x is minus cosec x into cot x. So similarly, integration of cosec x into cot x dx will be minus cosec x. Just reverse. Now you know the identity of d over dx of a power x upon log a is equals to a power x. If you are not knowing this, you know very well that d over dx of a power x is what? A power x log a. Right or not? Or base e? This you know. So that means, just suppose we are finding d over dx of a power x upon log a. What will it be like? See, 1 upon log a is a constant, so you will take outside. Okay, into d over dx of a power x. Right or not? So now you will solve it. 1 upon log a will remain same, into a power x, d over dx of a power x will be a power x log a. So this will be cancelled out and you are getting the result as a power x. So if you can say that d over dx of a power x upon log a, d over dx of a power x upon log a is equal to a power x. That means what? We can say here that integration of a power x dx should be equal to a power x upon log a and plus c. Yes or no? So you can check over here. The same formula we are getting or not? Yes. That integration of a power x dx will be a power x upon log a. Just reverse you have to do. I hope you understood this part. Okay. Now, you know d over dx of e power x is equal to e power x. Because this you can say this is a stubborn. That means ये बहुत जिद्दी है. ये ऐसा function है which will never change. We are having some kind of student like they never change. They want to do the same things again and again. Right or not? We have some kind of habit, maybe some good habits or maybe some bad habits, right, that we don't understand about anyone. We always do what we want, right? So here this is a function like this. When you differentiate this function, you will get same as the answer, no changes. It will never make any changes. So similarly, when you integrate this function, you will always get the same, and plus c you can write in all, right? Plus c you can write in all the integrations, because you know plus c is a constant of integration. So you can write plus c here also, you can write plus c here also, you can write plus c here also, here and here also, right? So next one is d over dx of sec x. We know d over dx of sec x is sec x into tan x, right or not? So here when you integrate sec x into tan x dx, it will be sec x plus c. And here the last one, d over dx of log x, we know 1 upon x. So when you integrate 1 upon x dx, you will be getting log x. I hope you understood this part, right? So see, maybe you have not done the revision of differentiation, but I have given you the revision of differentiation also. That what are the formulas we used in differentiation and how you will get the integration part also, right? So you got both the things like differentiation also and integration also. Now we are going to the some of the question, so you will get better understanding about integration. Okay, yeah. So let's see over here. These are some basic questions which we are going to do. Okay, so here let's start with the very first question, which says integration of x power 6 dx. So I would suggest you, as we go for differentiation, right? Whenever we go for differentiation, what we do basically, we always, just suppose I am saying to you, find out the differentiation of x power 6. So what do you do basically? You always take y is equals to x power 6. Yes or no? Okay. And you write d over dx on both sides. Right or not? Like this you solve. But when you integrate any function, so always use I over here. You can write I over here. Let I is equals to, you can write here, let I is equals to integration of x power 6 dx. So that will be easy for you to solve it further. Okay. So when you differentiate, you take y. When you integrate, you take I. Okay. So this is just a process to make your presentation correct. Right. Now, let's solve it. Recently, we have studied a formula, right? The integration of x power n dx is equals to what? X power n plus 1 upon n plus 1, right? Recently, we have studied this formula and plus c. Okay, so we can apply this formula over here and you will be getting your answer. Okay, so see, When you apply this over here, so I will be is equals to x power 6 plus 1 upon 6 plus 1 and plus c. So result will be x power 7 upon 7 and plus c. This is your answer. That's it. If you are knowing differentiation, that will be very easy for you. The same formula you have to apply, but just in reverse operation. Okay, see over here. This is 5 upon x, right? So you must be knowing, first of all, I am giving you the example. So you can take 5 as a constant outside. So first of all, I am writing let I is equals to integration 5 upon x and dx. Right or not? So what will you do now? Now you will take 5 outside. So you'll be having integration of 1 upon x dx. Now you know very well that differentiation of d over dx of log x is what? 1 upon x. So when you integrate 1 upon x, you will be getting dx log x or not? Yes. So here you will be getting 5 integration of 1 upon x dx will be log x and plus c. That's it. This will be your answer. Okay, but we are having one more thing. That just suppose you forgot that what is the integration of 1 upon x dx. You forgot the formula, right? Maybe sometime it happens. So what will you do now in this case? See, we are having one more choice to do. What choice we have? See, what will we do? We will take I is equals to 5, we will take outside integration. 1 upon x I am going to write as, sorry, okay. So when you take 5 as outside, it will be remaining like 1 by x dx, right or not? Yeah. So what will you do now? You will write I is equals to 5 will remain same integration. This can be written as x power minus 1 dx or not? Yes. Yes or no? Yes. So I is equals to 5 will remain same now. Integration of x power n dx. Recently I have studied the formula. So we will apply it over here. So x power n plus 1. That means what? Minus 1 plus 1 and divided by minus 1 plus 1. Right? So what will you do now? Plus c. So I will be is equals to 5 into x power 0 upon 0 plus c. So now, if you are getting 0 in the denominator, right, this becomes infinite or not? Yes. That's why we have already conveyed to you that whenever you are getting this condition, in the case of only 1 by x, I'm talking about the condition only 1 by x, so you have to apply this way. Which way? This one, which we did the previous one. Okay, only for 1 by x, right? Or if you are having any other like 1 by x square, 1 by x power 1 by 2, then you can apply the same process which you applied over here. Because for x power 1 upon x power 1 by 2 will not be x log x 1 by 2, right? That's why when you get only 1 by x, we are having the formula as 1 log x dx. So you can directly write over here. I hope you understand this point. That's why we have directly applied the formula over here. Okay. So let's remove this out and we are going to do the next question. Or if you are facing any doubt, you can write in a chat box. Okay. Now let's move to the next one. See, now we are considering this I is equals to integration. This we can write as x power minus 1 upon 4 dx. Reason? We are not knowing the direct formula of 1 upon x power 1 by 4. This can be solved by the different method as we applied over here. So you can write here I is equals to, you can write this as x power minus 1 by 4. This makes so much problem. Sorry everyone. I don't know what is going. Wait a minute. Okay. So here you can apply like x power minus 1 upon 4 plus 1 upon minus 1 upon 4 plus 1. Right? Reason? We have a formula like x power integration. Okay. Hello, Helly. Can you hear me? Good evening. Very good evening. So, from which class do you belong, my dear? Okay, thank you so much if you can hear me. From which class do you belong? 12th, okay. From the ISC board? Okay, very good. So, have you studied about integration? Very good. So, here we are just going to applying the basic formulas of integration. So, I hope it will be helpful for you. Yes, great. So as you can see that here is x power minus 1 upon 4 dx. So we can apply the identity that is x power n dx is equals to x power n plus 1 upon n plus 1. Right. So here we applied over here and we can also write plus c as a constant. Okay. Now it will be like x power minus 1 upon 4 plus 1. It will be plus 3 upon 4 and divided by 3 upon 4 plus c. So you can write 4 upon 3 x power 3 upon 4 plus c. This will be your answer. Right? Beta, I am from Unacademy. I teach on Unacademy. Right? So now we are having one more question to be done. So I just want you to solve this question by yourself. Try it and just mention your answer. I'm giving you 2 minutes to solve it. Okay? Please try. Or if you're not getting, just let me know. So I'll do for you. Try it. Please try it. Do it. No issues. Sure. Take your time. I've given you 2 minutes. If you are facing any problem, just let me know. So I'll help you out. Okay, great. Yeah, sure. I am waiting for you. Just crack it. Okay, so now I'm doing. You can match your answer, Heli. Okay. See, first of all, you will take I is equals to integration 1 plus x square upon root x dx. Okay, great. If you have done, you can match your answer. Very good. So our first step will be like that we will separate this denominator like 1 upon root x plus x square upon root x, and dx will remain same, no changes. Now integration. This 1 upon root x can be written as x power minus 1 by 2, right? And plus this can be written as x power 2 into x power minus 1 by 2, and dx will remain same. So now integration is equals to, here will be like x power 1 by 2 will remain same, plus x power 2 into x power minus 1 by 2, both will be added. So you will be getting x power 3 by 2 and bracket close dx. Now we can integrate them separately. So it will be like integration of x power minus 1 by 2 dx and plus integration x power 3 by 2 dx. So I hope, Hali, this much is same for you. I hope you have done the same. Now I is equals to, here we are applying the identity. Great. Minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 plus x power 3 by 2 plus 1 divided by 3 by 2 plus 1 and plus c as a constant. I is equals to 1 minus half will be half only. So x power 1 by 2 upon half plus this becomes x power 5 by 2 upon 5 by 2 plus c. This 2 will be taken in numerator. So 2x power 1 by 2 plus 2 upon 5 x power 5 upon 2 and plus c. This will be your answer. Right? I hope you are also getting the same. Great. Now, next question. Try this one. I belong to Rajasthan. Great. Now solve this one. First of all, apply the identity over here as a minus b whole square. First, Open the function by applying the identity, then try to integrate. Now you solve yourself. I'm solving over here. So in last, you can match your answer with me, right? So this will be like x square plus 1 upon x square minus 2 into x into 1 upon x. Bracket close, dx. Sorry, beta, this cannot be shared. Okay, you can join my Telegram channel, and the link is already given in the description box, so you can join from there. So you will get the updates of regarding the classes, right? So here x will be cancel out. Integration x square plus 1 upon x square minus 2 and dx. Now I is equals to, now we are making them separate. So integration of x square dx plus integration of 1 upon x square I am writing as x power minus 2 dx, and minus 2 will be taken as outside integration dx. But I don't know about other educators, but sorry, I can't share my contact number. You can join the Telegram channel. From there, you will get the updates, right? So here it will be like x power 3 upon 3 plus. Here we will be getting x power minus 2 plus 1 upon minus 2 plus 1. Minus 2 integration of dx. This I would like to help you out. Okay, Telegram channel link is not working. No issues. I am sending right now in chat box. So you can join from there. Right? Give me a minute. You can join from this link. That will be easy for you to connect. So now I would like to help you out with integration of 1 dx. See, integration of 1 dx is always x plus c. How? As you know, that d over dx of x is always 1, right or not? That's why integration of 1 will be x. Okay. So here we can directly write 2 into x, and in last we can write as c as a constant of integration. So I is equals to x power 3 upon 3 plus this becomes x power minus 1 upon minus 1 minus 2x plus c. So now in last we can write x power 3 upon 3. This minus will be multiplied into plus. So minus x power minus 1 can be written as 1 upon x minus 2x plus c. So this will be your answer. I hope you understood this. Now I would like to help you out with the some of the feature of Unacademy. First of all, as you see here, that you are having a comfort of taking live classes from home. Okay. Hello Chandan, how are you? And you are having unlimited access to all the courses. That's fine if it is clear to you, Heli. and we are having top educators of India on the one platform, and we are having regular doubt sessions. We are having coverage of syllabus also. We are having mentorship and guidance. We are having study material in PDF format, right? And we are having practice sets. We are having live test series, batch courses, everything. That means we can get everything at one platform. So you can use this referral code which is written over here. That's Sanam J Live, SANAM JLIV, Sanam J Live, to take the advantage of the free classes which are going to be conducted on regular basis. Okay, okay, beta, it always run at 5 to 6. On YouTube, we are running from 5 to 6. Or if you want to attend the plus special classes, then I'm going to give you the time. Yes, 5 to 6. On YouTube, it is 5 to 6. And on special class, if we talk about on Unacademy, for class 12, the timing is 7:45 to 8:45. The timing is 7:45 p.m. to 8:45. Okay, so you can use this code which is Sanam J Live, and you can take the advantage to watch the free special classes related to your syllabus. Right now, here recently we have launched the batches for class 11th and 12th. Okay, both, and which is started from 3rd of January. These are some crash courses in which we are going to complete the whole of syllabus of term second examination. Hali is saying, sir, you not reply me that why bio not taking classes. But I don't know the bio, I don't know about bio. Okay, I can help you out with maths. But maybe some of the reason can be there that biology subject sir has gone somewhere, maybe on leave. That after that the classes will be started, right? So we are having all the subjects like physics, chemistry, maths, and bio in one batch, as we are calling it champion batch, which has been started from 3rd of January. And here, which is another batch which has been started from 17th of January. That means recently it is started. And here also, if you have not studied anything till now, you can join these batches, right? And the batch name is Mavericks batch. Okay, so you can be a part of this Mavericks batch and you can use my code. So you will be getting the subscription eligibility, right? Which is going to be taken on 24th January, that is Monday. Okay, the timing is 7:45 to 8:45. As I told you, that special class is going to be taken for class 12th at 7:45 to 8:45. And the topic I have already mentioned over here. So the link will be given in the description box. Or if it is not given, then you can go for Unacademy app and you can download, you can go from there, right? You can search from there. Timing will be mentioned over here. So it will help you out. Definitely you can take part and you can use my code that is Sanam J Live and you can be a part of that batch. Right? And what are the advantages of taking special classes, which I am going to tell you, that you are having the special classes, like you will be having an advantage of taking polls, right? And you will be having the advantage of compete with your friends, and you will be getting a poll leadership board which shows you the performance of you in live class, right? And you can also ask your queries by writing your questions in a chat box, or you can upload the image also, right? You can also upload the image, you can, it will help you out to clear your doubts. And so for that, if you have not downloaded the Unacademy app till now, So you can be a part of it, like you can download, you can click on get started, then you can write your contact number, so you will be able to log in. After that, you can select your class. Just suppose you belong to ISC class 12th, so you can place over here. Okay, sure, bye bye, take care. And here you can also write, you can also click on the description video, so it will give you the updates about the notify me, right? When you click on notify me, it will give you the updates regarding your special classes, right, before 10 minutes. So there you can apply my code, which is Sanam J Live, so it will give you the free classes. Okay, now let's discuss about this question. So how many students are here? They can be a part of this. Okay, and they can try to do it. First of all, we will take I is equals to x power 3 by 2 plus twice of e power x minus 1 upon x dx. Understood? So here, now you can apply the integration part. Yes, Sanam J Live, correct one. So Heli, try to do this question if you can, and let me know the answer, or you can match your answer with me. So first of all, we'll separate the integration. X power 3 by 2 dx plus 2 will be taken as outside, and integration e power x dx minus integration 1 upon x dx. Sure, you too. Now, x power 3 by 2 plus 1, after applying the identity, we can write here. Okay, so here you can apply the identity. So x power 3 by 2 plus 1 upon 3 by 2 plus 1 plus twice of integration of e power x is e power x minus integration of 1 upon x is log x, and plus c. So now in last you can write the answer as I is equals to 3 by 2 plus 1 becomes how much? 5 by 2. So you will be getting x power 5 upon 2 upon 5 upon 2 plus twice of e power x minus log x and plus c. I think my pan is making some issue. Just give me a minute, everybody. It's not working well. That's why it is going to be happen. Okay. Now I is equals to x power 5 5 upon 2 upon 5 upon 2 plus twice of e power x minus log x plus c. Now you will be getting 5 upon 2 as 2 upon 5. So 2 upon 5 x power 5 upon 2 plus twice of e power x minus log x plus c. So this will be your answer. Okay, now let's move for the next one. We have a question like integration of 3 times of x square plus x plus 1, and here we are having x cube minus 1 dx. So first of all, what to do? See, here it is given like x cube minus 1, right? So we can apply the identity of a cube minus b cube over here. Okay, so that will be easy for you to do it. Okay, so try everyone. I hope that you will be getting it. Okay, try. I'm giving you time for 2 minutes to do. Here's some technical issue. Till the time we can solve your question. Yeah. So here you can apply the identity of x cube minus 1. Right. So it will be like, okay. So here I am writing the identity of a cube minus b cube. That will be like a minus b and bracket a square plus b square and plus ab. So you can apply this identity. That means if we write x cube minus 1 cube, it will be like x minus 1 bracket x square plus 1 square plus x into 1. So we can replace this value over here. Right. So integration 3 times of x square plus x plus 1 divided by 5. Here you can write x minus 1. You can write x square plus 1 plus x. You can write here 1 plus x bracket close and dx will remain same. So this will be cancelled out because both are same, and 3 upon 5 we can write outside. So this will be like I is equals to 3 upon 5 integration x square x square has already removed. We will be having dx upon x minus 1. Okay, so as we know, integration of 1 upon x is dx. 1 upon x dx is what? Log x plus c. So if we find the integration of dx upon x minus 1, it will be log of x minus 1 plus c, and in place of x we have log we have x minus 1, so you can differentiate this and you can write the differentiation denominator. So here you need to write here differentiation of x minus 1. See, when you apply the chain rule in differentiation, you have to apply d by dx in multiplication, but it just opposite in integration, that you have to apply the chain rule. So you have to write the differentiation in denominator, right? So differentiation of x minus 1 will be 1 only. Chandan, we are doing about integration, right? Recently we are just doing about integration. And if you talk about plus course, that we have started from 17th of January only. So you will be having, if you want to join it, so you will be having a recorded sessions also, and recently the chapters are going, so you can be a part of that, right, Chandan? You will get the classes for every chapter. Okay, and you will be having a regular doubt session, so you can clear your doubts in them, because after every 2 or 3 class we always take the doubt session, so it will help you to take out your doubts. Okay, so here we can write 3 upon 5 will remain same, dx upon x minus 1 will be log x minus 1, right, and plus c, because differentiation of x minus 1 will be 1 only, so we can directly write 3 by 5 log x minus 1 plus c. This will be your answer. Now I want you to do this question at home by yourself. Okay, because here you can apply the identity of a cube plus b cube. Okay, which will help you out to find out the answer. Here this can be done as x power 3 plus 2 power 3. So you can write this as x plus 2 bracket x square plus 2 square minus 2 into x. This is your identity. that a plus b, a square plus b square minus ab. So here you will be getting x cube plus 8 is equals to x plus 2 bracket. This will be like x square plus 4 minus 2x. Okay, so you can replace x power 3 plus 8 from this. So your calculation will be easy for you, right? So you can do this question at home. So I hope this session was helpful for you and you understood about the concept of integration. And this question also I am giving to you to solve at home. You can note down these two questions. Okay. And I'll definitely meet you by the next day and we will do more questions on it. Okay. So in last, I would like to say that be with Unacademy because here you will get all the features at a particular platform. So it will help you out to learn so many things, right, at a time. So you can use my code, which is Sanam J Live, which is written over here, and you can be a part of crash course. So thank you so much to be with Unacademy. Okay, and you can crack your exam, and I'll suggest you to take the subscription, which will help you to learn all the chapters or all the content related to your syllabus. Right. Thank you so much. Bye bye. Take care. God bless you.